Hello, this is Mr. Wynn, and this video is rational root theorem and some other special ways to solve polynomials. It is for pre-AP only, so if you're regular, you do not have to watch this or copy it down. So when solving a polynomial using the depression method, we had to find the factors or roots so we can know what to use while doing synthetic division. Sometimes we were given hints, which we used, and if we didn't have hints, we had to use a calculator to find the obvious roots, which is still the fastest way. But the third and true option is to use the rational root theorem. What that says is, if there are any rational roots as solutions, and rational means the answer is a fraction, a whole number, or an integer, it will be in this list of plus or minus p over q. P will be a factor of the constant term, and q is a factor of the leading coefficient. So if we go back to the problem we did a long time ago, 2x to the fourth plus x cubed minus 16x squared plus 3x plus 18 equals 0. Let's just list all the possible roots. So p comes from the constant term right over here, and q comes from the leading coefficient right here. So I'm going to figure out what times what is 18. Well, we have 1 times 18, 2 times 9, and 3 times 6, and 4 doesn't go in there, 5 doesn't go in there, 6 is already there with 3. So what's everything there? For q, what times what is 2? We used to have 1 times 2. I'm now going to make a list of every possible plus or minus p over q. So plus or minus, let's do all the ones first. So 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 6 over 1, plus or minus 9 over 1, plus or minus 18 over 1. Then I have to do all the 2's next for q's. So the p is 1, the q is now 2. The p is 2, the q is now 2. P is 3, q is now 2. P is 6, q is 2. P is 9, q is 2. P is 18, q is 2. Alright, that's every possibility. Now you should get rid of any repeats. So the first one's 1, then 2, then 3, 6, 9, 18, that's good. Then for the fractions, 1/2. Then 2 over 2, that's just 1, that's a repeat, so I'm going to ignore that. Alright, 3 over 2 is new, 6 divided 2 is 3, so that's out. 9 over 2 is new, and then 18 divided 2, well that just reduces 9. So anything that I did not cross out is a possibility. Now technically those are all your guesses to do in the synthetic division box. I tried positive 1, then negative 1, positive 2, negative 2, positive 3, negative 3, positive 6, negative 6, positive 9, negative 9, positive 18, negative 18. Then positive 1/2, negative 1/2, positive 3 over 2, negative 3 over 2, positive 9 over 2, negative 9 over 2. Eventually you'll find an answer. But remember, once you find an answer, you get a new polynomial, then you repeat the process, and eventually you'll get the right answers. But it takes a long time, and it's just guessing. So if you use a calculator, you get the answer right away. If I go back to the problem, remember the answers were negative 3, which is right here. Negative 3 is in that. Negative 1 was in this, so I would have found the first answer pretty early. Positive 3 over 2 comes from this one, and positive 2 comes from this one. Alright, so see, all of the fraction or whole number answers will be in that list. There will be a question about this on your test and your final, so you must know how to do this. I'm not going to make you plug all of them in, but just build a list of possibilities. So every factor of p divided by every factor of q, make sure you have a plus or minus sign in front of them. Alright. Sometimes, well, let me say this. Sometimes the depression method can always be used, but there's sometimes a faster and simpler method. Alright, so if you see the faster, simpler method, do it. If not, just use the depression method. It has a lot of synthetic division, but it always works. Again, keep in mind that these next methods don't always work. The first method is factoring using sum or difference of cubes. That's the sub formula. We've done that before. Second method is factor by grouping, which we've done before. Third one is factor using U substitution, quadratic form. Sometimes we call it U sub. That's really famous, but I'll show you that because we have not used that before. So the first one, using the sum or difference of cubes, the sub formula. Remember, if you have a problem, you cube root both things. So let me do that. I can cube root 8. I can also cube root x cubed. Cube root 8 is 2. Cube root x cubed is x. That's your a term. Then I'm going to do cube root of 27. Well, 3 times 3 times 3 is 27. That's my b term. You fill in the parentheses. The short parentheses, long parentheses. So the first thing goes first, the second thing goes second. And the long parentheses 3 terms, the first thing is the first thing squared. So 2x times 2x is 4x squared. The middle is just multiply a times b, so 2x times 3 is 6x. Then the last thing is the last thing squared. 3 times 3 is 9. Use SOAP for the signs because same, opposite, always positive. Same as subtraction is subtraction. Opposite subtraction is addition. Always positive. Alright, so I just factored this. Once you're factored, you know you set them equal to 0. So if I set this equal to 0, 2x minus 3 equals 0. I can solve that by adding 3 and then dividing by 2. That's one answer. That's 3 answers though because the exponent is 3. To find the other 2 answers, I gotta set this second one equal to 0. So let me do that. Now sadly, this second one is not factorable. If it's not factorable, you have to do quadratic formula. So a is 4, b is 6, c is 9. I fill in the formula, -6 plus or minus square root, parentheses b squared minus 4ac, all over 2 times a. I work on the inside, -6 plus or minus square root, that's 36. And then, alright, that's -144, all over 8. I'm still working on the inside. So let's do this. -6 plus or minus square root. That is -108 over 8. Now, inside's negative, the discriminant's negative. That means there's 2 imaginary answers. There's no real, but I do want to find them. So I can't square 108, but I can take out an I and then figure out what 108 is. So let me do this. So it'll be I square root positive 108. I have the tree branch here. So that is 9 times 12. 9 is 3 times 3. 12 is 3 times 4. 4 is 2 times 2. We circle our pairs. Here's a pair of 3s. Here's a pair of 2s. Pairs go out. So 3 goes out. A 2 goes out. The I is still out there. And inside that lone 3. So that really means this is 2 times 3 is 6i square root 3. Alright, so let me go right here. This equals -6 plus or minus 6i square root 3 over 8. I can reduce that. The -6, positive 6, and 8 are all divisible by 2. So that's going to be -3 plus or minus 3i square root 3. Can't change the square root number. All over 4. So I final answer. That's 2 different separate answers. Because of the square root left over, or I, you don't split them. So I found all 3 answers. There's 2 imaginary and 1 real here. Alright, the next one is factor using grouping. You split the problem into 2 same-sized groups. You pull out the GCF of each. Both parentheses should have matching things inside. That matching parenthesis will be the new GCF. So in this problem, if you notice, they didn't really combine it. You could actually combine the x squared together, and then do depression, but they split it for us because they want us to see the grouping pattern. If I make 2 same-sized groups, this is my first group. Actually, if I do like that, I'll reach a dead end, so I'm going to be smart. I could see ahead, but Josh, let's try that. I'm going to rearrange these 2. Alright, so let me write the problem. X to the 4th plus 7x cubed plus 10x squared minus 4x squared minus 28x minus 40 equals 0. Alright, the reason I did that is because I did not see a good GCF for the first one and second one that would make the parentheses matching. Here's my first group. What's the GCF of that? I can take out x squared. I'll take out x squared. What's will be x squared plus 7x plus 10. My second group will be this thing. Because the first thing's negative, I gotta take out a negative. 4 goes on all of them. This will be positive x squared. I'll take out a negative 4, makes it positive 7x. Divide by -4, so -4 divided by -4 is positive 10. Alright, so notice that the parentheses are matching. If they match, that is my new GCF. I'm going to take it out. So x squared plus 7x plus 10 is pulled out. And the second parenthesis will be x squared minus 4. That equals 0. I'm going to say each of them equal to 0. Actually, I'm going to factor them some more because that's faster. So if I factor this, that is xx 52 plus plus. The second one is the different squares. So I know that's xx 2, different signs. plus minus equals 0. I'm fully factored. I can now solve each one. If I set them equal to 0, the first one is x equals -5. Second one, x equals -2. Third one, x equals -2. That's a repeat, but I'll write that. The fourth one, x equals +2. Alright, if there's a repeat root, we'll call it a double root. It'll make the graph bounce. But those are my answers. Alright, if you did depression, you still got the same answers. Alright, the last one, a new one, is called U substitution, quadratic form. This is just a visual trick. It makes the problem look easier. If the bigger exponent of x is twice the smaller exponent of x, you may temporarily let u equal the smaller, or x equal to the smaller exponent in U substitution. Then you solve the problem like normal. At the very end, you undo the temporary U substitution and solve the new problems. So right now we have a quartic equation, x to the 4th power, x squared, and no x. If you notice, x squared, or x to the 4th, is double x squared. So I'm going to say, well, let's let u equal x squared. And let me actually write this one more time for you. Let's try this. If you know your exponent rules, this is x squared squared. This is x squared to the first. Alright. If I'm going to change x squared into u, then I'm really saying this is 18 times u squared minus 21 times u plus 3. So my problem that looked like I had 4th power is now quadratic. If it's quadratic, you solve in factoring quadratic formula. This is factorable. I see a GCF of 3. I pull it out to be 6u squared minus 7u plus 1. I'm going to factor that because that's faster. Let's see, this will be, is it 3 and 2? That will not work, so it'll be 6 and 1. 6u, 1u, 1, 1. I need a -6 minus 1 is -7. Negative is positive. From here, I solve each like normal. So the first one, if I do 6u minus 1 equals 0, and u minus 1 equals 0. Here I get u equals +1, 6. And here I get u equals +1. So I found what u is. I solve like normal. So let me go over here. So u equals 1, 6. U equals 1. Now the problem wasn't about u, it was about x. So now I have to undo the u substitution, the u sub. So u is actually x squared, so I'll put it back to x squared. So x squared equals 1, 6. And x squared equals 1. Solve for x. Well, the fast way is to square both sides. But when you square roots, make sure you have plus or minus. And I'll just leave it like this for now. We'll fix this later on. There's 2 of my answers. I square both sides here. X equals plus or minus 1. I found all 4 answers. So that is U substitution. That's the whole video. Thanks for watching. Ask questions class. See you soon. Bye.